Hello, you're welcome back to lesson 12 of sequence, and this is the last lesson on sequence. So we are talking about real world problems in mathematics. Okay, we want to talk about real life application of sequence, real life application of sequence. Okay, so we are trying to find different areas that sequence applies to. All right, so you could see from here that salaries all right, so when you are given this scenario you can work it out. Bank investment. Okay, so sequence are applied in investment. Sequence are also applied in population growth, and sequence is applied in savings. Okay, so the question is that which of these are arithmetic progression, which are geometric. Okay, so do your very best, look through it and identify the types. Okay, so this is the real issue with solving mathematical problem, especially when they are in word problem. Okay, so the hardest part of application problem is not the mathematics. No, you know how to write these ones, you know these values. Okay, you know the first term, you know the common difference, you know the position, you know how to find the end term, you know how to do those things. The challenge is how you can identify this information in a problem. Okay, how you can extract the key information in a problem. So please do to do a lot of word problems. Okay, it helps you identify key areas that you need to solve your work. All right, so we've gone through the whole of sequence. Now this is a 4-step process that can help you solve either arithmetic problems, so either algebra problems, or when they are in word problem. Okay, so the first is to read the context. Please, whether it is algebraic or word problem, please read the context and identify the identities. Okay, get your values that you need to work from it. Then you classify, you find out, is this going to be arithmetic or is it going to be geometric? Okay, then you know which formula to apply. Okay, so now let's talk about the salary. Okay, we saw that 4 different examples, few examples that we can use sequence for. So salaries, bank investment, savings, population growth, we can use sequence to resolve them. So a teacher earns 2,000 cedis in a year and gets a 300 raise every year. How much does she earn in 8 years? So we know we know our first term. We can deduce that our first term, the initial amount, is 2,000. Okay, and how much is added? Fixed addition is 300. Okay, and we are asking, when n is 8, what will be the amount she gets in the 8th year? Okay, so here we are looking for the value, the amount of money she will get, or she get at the end of the 8th year. Okay, good. Quantest convert annual salary with fixed yearly increment. So this is an example of AP. Okay. All right. So we move on to classification. Okay. Arithmetic progression and geometric progression. See, we have kept on repeating these key information so that you understand them and use them appropriately. Okay, so addition or subtraction, multiplication, or percent, which is half. Okay, percentages are fractions. Good. The signal is common difference for AP. For GP, we have common ratio. So in real life situation, fixed raises, all right, like the teacher's salary, uniform saving, taxi fare by distance. Okay, yes. And for GP, compound interest, population growth. Do you remember the formula for compound interest? Okay, so it's an example of GP, population growth, depreciation, variable spread. Okay, these are exponential values. So that is it. Okay, now percentage, when you are calculating ratio, please, in real life application, we are talking about real life application here, percentage growth. All right, so we are saying that to find the ratio, the common ratio, we use 1 plus p divided by 100. Okay, where p is the stated percentage in the question. So for example, if I say the percentage growth is 2, okay, if I say the percentage growth is 2, all right, then you have to remember that what will be the next. Okay, so you see that common ratio, we find it with the next, let's say the next item, let's say term 2, yes, the second term. Okay, first and second term. All right, so to get the common ratio, I have to link these two together, this divided by that. Okay, but yes, here we are given percentage change, and we are saying that the one here is representing the first value. Okay, the first term. So the first term is 100%. We are assuming that before you increase anything, it is 100%. Then afterwards we calculate for the for the other increment. So for example, if we say growth by 30%, 23%, okay, it is 1.23. So it is 100% plus 23% all divided by 100%. Okay, so 100 we divide 101, that's where we got the 1 from. Then 23 divided by 100. Okay, so that is what we are seeing here. So investment, population growth, depreciation, or halves each. Okay, good. So this is something you have to be conversant with when you are writing. For example, in a statement form, in you are trying to write a statement, you are trying to write an expression, a question. We try to limit this, discourage this. Okay, the A term is that no, put them in question form in year 8. Okay, when you are answering, please, when you're writing the question, you're answering, don't just write. I always been telling you, your solution should be in statements. When you are done, therefore, you state it work clearly so that it will give better understanding. So we don't say, therefore, the A term equals 4,100. No. So therefore, in year 8, the chair salary is this. Okay, this is better. All right, good. So always include the cities, the unit, people, years is very important. Good. Name exactly what the answer measures. Salary. Here is salary. Good. And is the number reasonable for the situation? Doubling starting salary, okay, after 7 raises makes sense. Like something like that. Make sure whatever you are answering or whatever you are writing makes sense to the reader. All right, so there is another one here. Okay, there's another sample here for you to work with it. Good. All right, so let's come to the bank investment. So we are extracting the initial investment, which is 100 cedis. Rate is 23%. Okay, we have already classified that percentages are GP, and the critical ratio, the common ratio, is 1 plus the percentage growth we are talking about. Okay, please pay attention. 1 plus the percentage. Okay, warning. If R is equal to 0.23, the investment catastrophically loses 77% of its value each year. Please, so we don't use this. We don't write this, not what it is. Okay. All right. So we are saying that always it is plus 1. We are assuming that the first money is 100%. Okay, then the increment, so plus the increment. Okay, it's very, very important for you to do that. So calculate the stats of year 5. Okay, you can easily do that. year 5, we have our R, common difference, we have our initial number, that is the first term. Okay, good. So the most important thing is to remember how to calculate the percentage increase. It is 1 plus the fraction of the percentage, okay, which is what we're talking about here. Okay, so we have worked with this before. All right, so we look at it again and do other manipulations and make sure that you understand this part very well. Okay, so these are common misconceptions. All right, the percentage collapse, the percentage, I was just talking about it. The percentage increase or percentage decrease, it's very important. The R is not equal to, please, it's not equal to, let's say the 23%, 23 over 100. No. Okay, look here. Growth adds to 1. Growth adds to 1. You must keep 100% of the original. Okay, 100% of the original. So it is always 100% plus the new increment or the stated increment. Very important. 100 plus, so 100% plus the new or the stated growth percentage, all divided by 100. Good. Let's come to the numbers. You have talked about it. You shouldn't be writing just numbers like that, okay? Make the statement, make it a complete statement. All right. And the next one is that assuming after 3 years, okay, sometimes you say that find the growth after 3 years. After 3 years, it means that it goes to the next year. Please pay attention. After 3 years, it means that it is the end of the 3rd year and the beginning of the 4th year, or in the 4th year. So statements like this should be very, very careful about it. Okay, because N represents the states after the change. So let's go to the next slide and see. Okay, so we have first year, 2nd year, 3rd year, 4th year. So if we say after 3 years of growth, so this is the 3rd year. If we say after 3 years of growth, we are referring to the 4th year. Okay, means you have completed the 3rd year and you are at the start of the 4th year. Therefore, after 3 years, N is equal to 4. Okay, so to remember, there is it. One time we say after. So after K years is N equals K plus 1. You can't say before. If we say before the 3rd year growth, it means that we have not gotten to the 3rd yet. We are still in the 2nd, which N would then be equal to K minus 1. Okay, right. If you don't use the exact year, please consider it before and after are 2 different things. All right, so basically we are coming to the end. I think we are at the end of our lessons on sequence. Okay, we have talked about the foundation. We have talked about the foundation. Lesson 1 to 4. We came to arithmetic progression. We came to geometric. we find our bridge and our application. Okay, so thank you so much for being with me throughout this journey. All right, good. So we have come to the end of sequence. Please use these notes, use these lessons alongside your learning materials to solve a lot of examples and tasks. Okay, if you have any challenge, reach out to me. Thank you very much, and God bless you. Our next topic will be functions. Functions. God bless you and take care. Bye.